This video is on how to name and write formulas for acids. The tricky part about this is first just determining if you have a binary acid or a ternary acid. Once you determine which kind, then it is much easier to, not much easier, it is easy then to either write the name or write the formula. There are some rules you will follow. So let's go through the rules, but before we do that, we really need to know what an acid is. So an acid is a compound that can donate a hydrogen ion. So a hydrogen ion, that's your H plus, okay? So really what we're talking about is anything that contains hydrogen will be an acid. So if your formula has hydrogen in it, like HCl, we've got an acid, or even like H2CO3, we also have an acid. All right, so both of those would be acids because they have hydrogen. So two types of acids, and they are binary and ternary. And distinguishing between these is probably the most important part of naming these or writing formulas. So first, let's talk about what a binary acid is. It's an acid that's made of two elements. And I just said that acids have hydrogen. So really what that means is you have hydrogen, obviously, for an acid, plus a nonmetal, right? That would make two things, two elements. All right, so naming them, okay? The rule is that it's going to start with hydro, it's going to end in ic, and it's going to be acid. Oh, let me fix that typo. So the part in the middle there, that blank, that's the stem of your nonmetal. So I'm going to write stem for your nonmetal. So if your nonmetal is chlorine, that would be chlor. If your nonmetal is nitrogen, that would be nitr. If your nonmetal is fluorine, that would be fluor. So you'll kind of see as we go through these that we'll actually end up doing all of the examples. So let's go through some examples. So HCl, I know that this is binary because I have hydrogen. Oops. I have hydrogen and one element, chlorine, with it. So my name is going to be hydro. Chlorine is in the chlorine stem is going to be in the middle there, ic acid. So hydro, and then my stem is chlor for chlorine, and then I put the ic acid on the end. So the next one, H2S, so again, binary because I have hydrogen in one element. So I start with hydro, and sulfur is actually going to keep the whole name for its stem. So sulfur, and then ic acid. All right, and then the last one here, hydrogen and nitrogen, so binary. So here I've got hydro and nitric acid. So that would be how you'd name a binary acid. So now let's talk about ternary acids. These are made of more than two elements. So what this actually means is you're going to have hydrogen and a polyatomic ion. So this is going to be something like in the beginning when I had like H2CO3. Okay, this is one of the reasons you need to be aware of and be able to identify those polyatomic ions. So when you're naming your ternary acids, what you do is you look at your polyatomic ion ending. So they end in ate or ite. So if the ending is ate, you just change it to ic. If it's ite, you change it to us. And that blank before it is whatever you had before it. For example, this H2CO3, CO3 is carbonate. So, oops, that's an A. So what I would do is I would just change the ate to ic. So this would be carbonic acid. And this is the acid you get in POP from carbonation. All right, so let's go through all 5 of these. All right, so first let's name our polyatomic ion. So here I have hydrogen and SO4. So this makes it ternary. So SO4 is sulfate. All right, so the 8 changes to ick. And sulfur, just like in up above when we did the hydrosulfuric acid, this right here. Sulfur, the stem is sulfur. We don't shorten it. So, but I do need to change 8 to ick. So this is going to be sulfuric acid. And notice I didn't put hydro in front. Hydro means it is binary. All right, so this next one, I have SO3. So again, it's ternary, but now I have sulfite. So this is going to be sulfur, but not ick, because ite changes to us. So sulfurous acid. So sulfurous, sulfuric, and then we have up above hydrosulfuric. So you could probably see where this could get a little tricky. You need to be very careful and know the rules. All right, next one, PO4. This is phosphate. Sorry, my pen doesn't want to work very well. So phosphate, 8 would go to ick. So phos, and here's where kind of like the sulfur, we put a little part back on from the element. Phosphoric acid. All right, next one, ClO4. This was not one of the polyatomic ions you had to have memorized. However, you should be able to look at your pink sheet to figure out what it is. You should be able to recognize that it is a polyatomic ion. So ClO4 is perchlorate. So 8 changes to ick, so it's just perchloric acid. And the last one here, ClO2, that's chlorite. So that is us acid. Oh, hold on a second. Let's try that again. Okay, none of these start with hydro because they're all ternary. Now, one way to remember this 8 and ick and ite with us is the little phrase, I ate something icky. So, ate ick. I ate something icky. Okay, so what if we're going the reverse way? What if we're trying to write the formulas? So you have to balance the charges of your H plus and whatever your anion in, exactly like we did before. But the key is this, that when you see acid in the name, that means it contains hydrogen, that you have H. Okay? When you see hydro in the name, that has nothing to do with it having hydrogen. Hydro means that it is binary. This is very important right here. This is where most students make the mistake. All right, so if I have nitric acid, okay, acid tells me I have H+. That's my cation. Nitric, okay, no hydro, so this is ternary. So that means I have a polyatomic ion. And ick goes to 8. So that I have nitrate, which is NO3 minus 1. So it's kind of like a little puzzle. You're like decoding this. So now I'm going to combine these to get my formula, just like we did with ionic compounds. So I have H and O3 because I only need one of each to balance them out. Okay, so let's do another one. Okay, hydrobromic acid. Okay, the acid tells me I have hydrogen. Okay, the hydro in the beginning tells me this is binary, which means I just have an element with my hydrogen, not a polyatomic ion. And it says brome. So brome would mean, oops, that's not what I wanted to do. Brome would mean that I have just bromine. And I look on my periodic table and bromine is a -1 charge. So I have a +1 for hydrogen, a -1 for bromine. So my formula would be HBr. All right, oxalic acid. So acid tells me I have H+. Oxalic, I don't have a hydro, so this is ternary. Ick goes to 8. So this is oxalate. So oxalate is C2O4 with a -2 charge. So now my charges don't match up. They don't balance out. So that means I need 2 hydrogens to balance out my oxalate -2. So H2C2O4 is oxalic acid. And then the last example we have here, acid is hydrogen. Hydro means it's binary. And so I just have an element. And the selen means I have selenium. So I look on my periodic table. Selenium is Se and it's a -2. So again, charges don't balance. So I need 2 H's to balance out this -2 from the selenium. All right, one last little thing. There is an exception, of course. HCN is named like a binary acid. So technically this is ternary because we have cyanide here. That's that polyatomic ion. And so what is the name actually? So HCN is hydro, even though it's ternary, we're naming it binary, hydrocyanic acid. Oops. And I usually have students ask why, and I don't know 100% sure, but I would guess that it has to do with the "ide" ending. We can't use the rule we had with ternary first, where 8 goes to "ic" and "ite" goes to "us." So we're going to name this hydrocyanic acid, even though it's a polyatomic ion, even though it's ternary. So that's how you name and write formulas for acids.